Hi everybody, we are in week 8. We're going to start linear programming this week. So this week will be an introduction to linear programming, and the next week we'll be doing some word problems to help you understand how linear programming is used in real life. In one single word sentence, linear programming is nothing but finding best possible solutions to practical problems. It's a technique used to find the best possible solution to practical problems. So it's basically a optimization tool. So what are the learning outcomes this week? By the end of this week, you should be able to write and recognize inequality symbols. You should be able to sketch graphs of straight line equations and find the point of intersection. You should be able to locate the integer points in the inequality regions. You should be able to highlight the regions that satisfy the inequalities. Okay, so what is linear programming? Before we go deep into that, let's first understand what is it? What is linear programming? Linear programming is used to find the best possible solution to practical problems, real life problems. For example, like maximizing the profit or minimizing the loss, or if you're involved with production, so maximizing the productivity or minimizing the cost, or to achieve the break-even point. So it is used to achieve the best outcome, yeah? And how is it achieved? By formulating the real life problem into a mathematical model, yeah? So you formulate the real life problem into a mathematical model. And what does it require? It requires some linear relationships, yeah? Mathematical model whose requirements are represented by linear relationships. That is, which involves objective functions. And the idea of the objective function is that it defines the quantity which needs to be optimized, yeah? And the linear inequalities which are subject to linear constraints. The constraints like what we saw in the second week, constraints like for example, if you take up a project like budget and number of employees or the number of products produced or the components, all these are constraints, isn't it? So the linear programming is nothing but understanding the linear relationships and drawing the graph and finding the best outcome, best possible solutions to practical problems when you have such constraints. So linear programming in one sentence, you can say it is used for obtaining the most optimum solution for a problem with given constraints. So it's actually a tool for linear optimization. Yeah, yeah. So that's what we're going to see. So what type of real problems are we talking here? For example, a delivery service must deliver 1,350 parcels to the next town. Lorries can take 150 parcels and vans can take 90 parcels. So look at the situation. Here, there are only 12 drivers available and at least 4 vans must be used. That means here we have a constraint here. Yeah, at least 4 vans must be used. That means at least 4 vans must be used. That is minimum number of vans is 4. So you can have 4 or more than 4. So you can write the inequality as B, the number of vans is greater than or equal to 4. It can't be 1, 2, 3. It can be 4 or more than 4. So that's why we have used the term at least. So understanding these type of inequalities will help you solve such problems. Another example, one lorry journey costs $300 and one van journey costs $200. Find the least possible cost for transporting the parcels. Again, the least possible cost. What are we trying to find here? We are trying to find the minimum cost. What is the minimum cost? So such problems can be solved using linear programming. So to understand how to solve linear programming problems, we need to be sure what is inequality and how to make inequality equations like this, yeah, and how to represent it graphically. Okay, so what is inequality? All this time, that is last couple of weeks, you have been using equations, yeah, but mathematics is not always about equations like equal signs, like the left hand side is equal to right hand side. It's not always like that. It's not always equal to some quantities. Yeah, it's not always like that. Sometimes it involves a quantity greater or less than a certain quantity. Yeah. So inequalities are the relationships between two expressions which are not equal to one another. Yeah. It could be greater than, it could be less than, or it could be greater than and equal to, or it could be less than or and equal to. Yeah. So for example, if I say more than 4 vans must be used to transport the parcels. I'm just taking an example, okay? What does it mean? That means I can have more than 4 vans. That is, I can have 5 vans, I can have 6 vans, I can have 7 vans, more than 4 vans. And how can I represent it as an inequality? I can just say B is greater than 4, okay? So another example, no more than 4 vans must be used to transport the parcel. What does that mean? No more than 4 vans. That means I can have 4 vans, I can have 3 vans, I can have 2 vans, I can have 1 van, but not any number more than 4. So I can represent this inequality like this, isn't it? Because van, the number of vans B is less than or equal to 4. Another good example, at least 4 vans must be used to transport the parcel. At least 4 vans must be used to transport the parcel. That means the minimum number of vans should be 4. So it could be 4 vans, it could be 5 vans, it could be 6 vans, but the minimum is 4. So I can write this as the number of vans is equal to 4 or greater than 4. So that's how you represent an inequality equation, yeah? Equations which involve inequalities. And the symbols used for inequalities are generally less than, greater than, less than or equal to, greater than or equal to, and sometimes it's not equal to, yeah? So we will concentrate on this, yeah? So now I want you to try these questions. Pause the video and click your answer there. Okay, so now I'm sure you're an expert to write and recognize inequality symbols. You're good at using words like no more than, at least, less than, greater than. So be careful when you're reading the question. Yeah, try to understand that and just convert those beautiful statements into mathematical equations. In this case, inequality equations, yeah? So now let's see how to sketch graphs of straight line equations and find the point of intersection. This is just to understand how to find the solution, okay? We have done this in week 5. So I'm going to take the same example and go through that quickly so that it's there, yeah? You just need to know this because for solving linear programming problems, you should be able to draw a straight line in graphically, yeah? Okay, so let's take this equation. So now, is this equation a straight line? If I ask you such a question, you would say, Yeah, it is, because it is of the general form y is equal to mx plus c. And what is the gradient here? Gradient m is equal to, when you compare these two equations, the general equation and the equation itself, you see that m is equal to 2, the gradient m is equal to 2, and the y-intercept c, that is the point where the straight line touches the y-axis, is called the y-intercept, isn't it? For example, if there is a straight line like this, this is c, yeah? That is a point where the straight line crosses the y-axis. So that is equal to -5. C is equal to -5, yeah? How do you do that? Looking at that straight line, it's clear that the gradient m is equal to 2 and the straight line is positive. That means the straight line, as you go from left to right along the x-axis, you go up, isn't it? So this, because it's a positive gradient, this means for every 1 unit you move to the right in the x direction, you move up by 2 units in the y direction. That we have seen that in week 5. And how do you draw the straight line for this? You first need to find a y-intercept. Yeah, you first need to find the y-intercept. From the equation, you can say that y-intercept is -5. That is, when x is equal to 0, y is -5. Next, find the x-intercept, that is, substitute y is equal to 0 and find the value of x. And then when you solve this, you will get x is equal to, take 5 over that side, 5 over 2, which is nothing but 2.5. Yeah. So you get 2 points. You can draw a straight line, but I would suggest that to choose another point. For example, in this case, x is equal to 4. Substitute 4 there. 4 2s are 8. 8 minus 5 is 3. So y is equal to 3. It's always good to have 3 points, even though it's okay to have 2 points. The reason why I'm saying that is sometimes the lines are so close to the origin, it is very difficult to find this point. Yeah. It's very difficult to find the y-intercept and the x-intercept. Yeah, this is if it is very close to the origin. Yeah, so I would suggest that to take 3 points at least. So now if you plot the points, you can clearly draw a straight line, which clearly says as you go from left to right, 1 unit along the x direction, you move up by 2 units. Yeah, 1 unit, 2 unit. So that is your gradient. So 2 by 1, m is equal to change in y-axis, that is 2 over 1, x-axis. Yeah. So that was your slope. Yeah. So you have 3 points. You can beautifully draw the graph. Now, how to solve the simultaneous equation by drawing 2 straight lines? We have seen that last week. Yeah. Oh no, this week, sorry. This week. That is y is equal to 2x plus 1, y is equal to x plus 1. Both are linear equation, as you can see. Yeah, both are linear equation. Why? Because it has got the highest order is 1. Yeah. So both are linear equation. And how do you draw the straight line for these 2 equations? We have seen it. Yeah. So you have to first find the y-intercept, then you have to find the x-intercept, and then get another third point and then draw the straight line. So for example, y is equal to 2x1, the c is 1. So that means the gradient is positive. That means the straight line will pass through this one and will go up because the gradient is positive. Yeah. Similarly, for this line, y is equal to x plus 4, the line should cross the y-axis at 4. Again, it is a positive gradient, so again the line should go up. But in this case, the gradient is 1. So for every 1 unit you go up, you have to go up by 1 unit. Yeah, because the slope is 1. Yeah. Okay, look at that. What is the point of intersection? 3, 7. Yeah, so that is a solution for these two straight lines. Okay, that means that's the point which satisfies these two lines. That's the only point which satisfies these two lines, because that's the point where these two lines intersect. You don't have any more solutions when you solve these equations simultaneously. Yeah. Okay, now we know how to recognize inequality symbols. We know how to we are an expert, I should say. Yeah, we are an expert how to draw straight lines and find the point of intersection. Now we can jump into inequalities. Let's combine these two and see how can we draw in straight lines which have inequalities, and how to highlight the regions that satisfy two or more inequalities. Okay, so for this example, what happens? What we are trying to say here is what happens instead of equal to, we have an inequality sign. How to find the solution that satisfies the two equations which look like this now. So we don't have an equal to sign anymore. We don't have the left-hand side equal to the right-hand side. So how are we going to solve such equations? Okay, so that's what we're going to see. Okay, how are we going to solve such inequalities? Yeah. To do that, let's take an example. Consider this line 2x plus y is equal to 3. Okay, so let's first understand what is the inequality. Yeah, what is the region? What is the inequality region? Okay, to understand that, let's first draw this line. You know how to draw a straight line. I would usually do y is equal to mx plus 3 and then find the y-intercept, then find the x-intercept, and then find another point and then draw a straight line. Yeah, something like that. Because here c is 3 and let me show you here. Y is equal to minus 2x plus 3. Yeah, so it clearly says that the line should cross the y-axis at 3. That's your y-axis and that's your, yeah, it should cut through C, 3, and the gradient is negative. That means the straight line should go down, because as you go from left to right, yeah, 1 unit from left to right, let me take a place where it is exactly 1 unit. Yeah, no, there's no place like that. Okay, I can take like that. So as you go from left to right along the x direction, it is going down. That is because it's got a negative gradient. Yeah. So in such cases, what you do is, so now this equation is for the equal to sign. Okay, that means all points on this line satisfies the equation, or you can say all the points on this line are the solutions for the equation. Yeah, that's what it means. Now consider the point 1, 1. Where is it actually? Yeah, that's there. 1, 1. Okay, let me rub that. Okay. Now I'm going to substitute this 1 for x and 1 for y. Yeah. And when I do that, I get at this point 1, 1, you get 3. Look at that. This point satisfies the equation because 3 is equal to 3. Yeah, this point 1, 1 satisfies the equation because it lies on the line. Yeah. Now let's take another point 2, 4. Do you think this will satisfy the straight line? No, because it's not on the line. Yeah. So how do we prove it mathematically? You can substitute 2, 4 in that equation and you see that it's 8. It's not equal to 3. 8 is not equal to 3. This clearly shows that the coordinate 2, 4 is not a solution for the equation and does not lie on the line. So 8 is greater than 3. Okay, That means what? All these regions are greater than, so y is greater than that point, isn't it? So let's see that, yeah? So it means 2x plus y is greater than 3. That's what it represents. Because it is this, when you substitute it, you get 8 greater than 3, yeah? And it does not lie on the line because it's not equal to 3, yeah? Now let's take a point on this side of the line. So you have seen this region, because this line divides this graph into 2 regions. So region 1 and region 2. Yeah, this line divides the graph into 2 regions. So region 1 is a region where 2x plus y is greater than 3. And if you take, for example, let's take the origin itself, which is very convenient. Yeah, in this case, if you substitute 0 here, so you have 2 times 0 plus 0 is equal to 3. That means we are saying that, is it 3? Is it equal to 3? No. What is it? 0 is less than 3. 0 is less than 3. Yeah, 0 is less than 3. That means all this region, in all this region, you have 2x plus y less than 3. Okay. So the line 2x plus y greater than 3 divides the whole plane into 2 regions. Okay. This region is 2x plus y greater than 3, and this region is 2x y less than 3. Okay, so the solutions of inequalities can be represented by regions on a graph. Okay, now I want you to pause the video and answer the question. Write down 2 integer points in the region 2x plus y greater than 3. That is, in this region, I want you to choose 2 integer points. And similarly, I want you to choose 2 integer points from this region and just write it down, yeah? Okay. Now let's see how to highlight the regions that satisfy the inequalities. How do we do that? Yeah. Okay. Or I can also say that this is a way to find the region for a single inequality, because we're going to solve with one equality first, yeah? So let's consider this equation. Shade the region for which x plus 2y is greater than or equal to 6. How do we do that? First step, draw a straight line for an equation of a straight line, yeah? So that is x plus 2y is equal to 6. You know how to do that, yeah? So draw the boundary line equation of equation x plus 2y is equal to, what I would do is transform it into y is equal to mx plus c form, which is more easy for me because then I can see clearly where the straight line crosses the y-axis. So I know that clearly by doing that, by rearranging it in this form, I can see that the straight line should pass through this and should have a negative gradient. That means my straight line should go down, because yeah, as you go from left to right, one division along the x-axis, you go down by 0.5 along the y-axis, 0.5 units, yeah, because it is half. You go down, yeah, and find the y-intercept by putting x is equal to 0. That's what you got, 3. Now you find the x-intercept, which is by putting y is equal to 0, and then you get minus 3. So 3 times 2 is 6, isn't it? So you get another point, 6, yeah? So you find both the points. So y is equal to 0, it becomes 6. And now join the straight line. Take a third point, because this is far away from the origin, so it's all right. You don't, it depends on the situation, isn't it? So when it is close to the origin, it is better to have a third point, but when it is not, it's all right. So you draw a straight line joining the 2 points, and then that's your boundary line, solid See, look at that. I've drawn a solid line. I'll tell you why, okay? So you draw a solid line, not a dotted line. Solid line means something very solid. A dotted line is like this. So sometimes you draw a dotted line, isn't it? Instead of a, yeah. So you use a solid line when you have this equality sign. When you have this equality sign, see, equality sign, you use a solid line. When you do not have, for example, if you just have x plus 2y is greater than 6, or x plus 2y is less than 6, you should use dotted line, okay? Otherwise, when you have the equality sign along with this less than or greater than, then you should use a solid line. So please use a ruler and pencil to draw these solid lines. Yeah, please do not just draw it roughly. It should be clearly drawn. Okay. Okay. So choose a test point in one of the two regions to see whether or not it satisfies the inequality. Then shade the required region. So for example, easiest way is to choose 0, 0. So you substitute 0, 0 there. And what do you get? 0 plus 0 is not equal to 6, and it is less than 6. So that means that's wrong. Yeah. So that means you have to shade that region. That region, this is not true. So that is the region which satisfies the inequality. So that is your region which satisfies the inequality. Which inequality? This inequality, x plus 2y greater than or equal to 6. Okay, now let's do another problem. Finding the region for two inequalities. So we have done here one inequality. Now let's find for two inequality. That is the region that satisfies two inequalities. So how do we do that? We do similarly, but now we have to draw two straight lines and then shade two regions. Okay, and see which the region where it overlaps. Okay, so shade and label with the letter R the region for which y is greater than 1 and x is greater than 2. So first what you're going to do, you're going to draw a straight line where y is equal to 1, and you know how to draw that. Y is equal to 1 is a straight line which is just parallel to x-axis. Yeah, which is just parallel to x-axis. Lightly shade the region for which y is greater than or equal to 1. Yeah, if you're getting confused, just substitute one point, that is the origin itself, in this equation. So you get 0, you substitute here 0, 0 is not greater than 1, so this is false, and that is the region which satisfies this inequality. Okay, what did I do? I just choose the origin, I substituted 0 there, and 0 is not greater than, it is less than 1. So this is a false region. This region does not satisfy the equation inequality, and this is the region which satisfies the inequality. So I shade this region. Now how do I draw that? X greater than 2. Again, I will draw a straight line for x is equal to 2. That means a line which is parallel to y-axis. Yeah, I think you got this in the exam also, isn't it? Some of you have got that y is equal to 1. Yeah. Now look at that. I've used dotted lines. It's why? Why did we use the dotted line? It's because we have no, it's just greater than, we have no equality sign here, you see? It is equal to sign here. That is, x is not equal to 2. X is greater than 2. So in these cases, you have to use a dotted line because any point on this line will not satisfy this inequality. If I take a point 2, 2 is not greater than 2. 2 is equal to 2. So it does not satisfy that. So that line is not included on this included in this inequality. Okay, so that is why you have to draw that as a dotted line. And any point 0, 0, if I take 0 is not greater than true, so this is my false region. Yeah, and any point on the right side of this line will satisfy this inequality. Okay, so you just substitute 0 origin and see, is 0 greater than 2? No, it's false. So that means this is not the region I want. This is the region I want. Okay, now look at that. Where does these two shaded region overlap? Yeah, so this is the place where they overlap. And that is the region which satisfies both inequalities. And then label it R, because the question asks you to shade and label with the letter R. Then shade it and label it. So in your exam, you have to clearly draw these straight lines. Remember the straight line, yeah? And then shade it, yeah? So you should remember that inequalities that use greater than or less than symbols are plotted with a dashed line to show that the line is not included in the region here, because 2 is not included in the region. Similarly, when you have this inequality symbols, you will plot the graph with a solid line to show that the line is included in the region. In this case, you see y is equal to 1. Every point on this line satisfies this inequality. That is why it is nice bold line, yeah, solid line. Okay, next. Inequalities that enclose a region of the plane. Look at that. We have 3 inequalities here. Now we are talking about plane. Yeah, how to find the area which satisfies all these 3 inequalities. Yeah. Okay. So draw a line y is equal to -3 in this case. Okay, that is a line parallel to x-axis. Now, how do you see whether it satisfies, which part satisfies? Yeah. So just put 0, 0. Let me put the origin itself, always origin. Yeah, I like to put the origin. Yeah, it's easy to use origin itself. So I put origin there, 0. Is 0 greater than or equal to -3? Is 0 greater than or equal to -3? Yeah, yes, it is. So that region is true. So you can shade, sorry, shade that region. Yeah. Now we have to draw the line x is equal to 1. X, because for this, first draw a straight line, x is equal to 1. So that will be passing through this. Yeah, x is equal to 1. Look at that. I have put a dotted line here. Why? We have used a dotted line here. Why? Because we don't have the equal to sign. It is just greater than 1. That means any point on this line does not satisfy this equation. Now, which side should we shade? So let's put again the origin 0 here. Is 0 greater than 1? Is 0 greater than 1? No. So that region is not true. Yeah, does not satisfy. So that is your region which satisfies. So lightly shade the region which is for which x is greater than 1. The last one, 2x plus y is less than or equal to 3. So draw the straight line for that. So it intersects at 3 and the x-intercept is, so x is equal to 0, y will be 3, and then find the x-intercept. Y is equal to 0, and what is x? 3 by 2, isn't it? 1.5. And then join the line. Okay, so now you have to find which region satisfies this. So put again the origin value. So you get 0 plus 0 is less than or equal to 3. Yes, it is true, isn't it? It's less than or equal to 3. Yes, it is true, isn't it? And then shade that region. So that is your region which satisfies the inequality. And now Identify the overlapping region, and that is this region. Yeah. So that is the region which satisfies all three equations. Okay. So this region, I'll just draw it. Okay, that region that satisfies all three inequalities, and then clearly label it. Please use a pencil, a ruler, a sharp pencil, ruler, and draw it clearly, yeah, neatly. Okay. So remember, a question may require you to shade the wanted region or the unwanted region. So in this case, in all these examples, this example and previous example, all these examples, we were shading the wanted region. That is the region which satisfies all the three inequalities. We were shading that. Sometimes you may be asked to shade the unwanted region. Yeah, I know it's a bit tricky because it doesn't work automatically, isn't it? So shading the unwanted region is more useful in linear programming. That is, and we are going to see that next week, especially when we are doing word problems, and you will understand why we do that. So that means for the same previous example, this is the region we were interested in, and we did everything opposite, okay? So for example, let me go back. So we shaded this region for the straight line 2x plus y less than or equal to 3. Now we are shading this region, you see? So it's all the unwanted region we are shading, yeah? And this region is called critical region. So this was our initial shading rule because we were shading the wanted region, and now we want to shade the unwanted region. And this white region, unshaded region, when we shade the unwanted region, is called critical region. And any point in this region is called a point in the critical region. Yeah. And it is very, very useful in linear programming. Yeah. To find the best solution to the limited resource problems. That is when you have constraints like budget or productivity problems like um, what are the like number of components or the number of employees and so on. Yeah. So when you have constraints like that, this is very important. Yeah, this critical region. Yeah. We're going to see that anyway next week, how to solve that. Yeah. Okay, the next example is inequalities that enclose a region of the plane. Yeah, again, we're going to just look at it by shading the unwanted region. Okay, let's do that. We'll do the same, we'll follow the same step, but now we're going to shade the unwanted region. So why is, oopsie, let me just go back. Yeah, in this case, we're shading this region. For example, if you put 0, the origin there, so 0 is greater than -3. So actually, this is the wanted region, but we're going to shade the unwanted region. Got it? Now again, x is equal to 1. You draw that and you see 0. You substitute the origin. Origin is greater than 1. So this origin is greater than 1. It's false. So this is your wanted region. You shade the opposite side. I mean, the unwanted region. Now, again, for this straight line, you shade the unwanted region because here again, 0 is less than or equal to 3. That is true. So this is your true region, but you don't shade this true region, wanted region, you shade the unwanted region. So you are doing it the opposite way now. Yeah. So you're going to shade the unwanted region. Okay. So identify the unshaded region. This unshaded region is the region that satisfies all the three inequalities, and then label it. Okay. Okay. So in summary, how do we solve a system of linear inequalities? We just follow 3 steps, just 3 steps. Yeah. The first step, draw the boundary lines, that is, draw the straight lines, boundary lines. Remember, dotted lines when you have greater than or equal to, yeah, because it does not include the points on the line itself, yeah. And for each line, shade the unwanted region, then the solution is the final unshaded region. Okay. So that is your critical region. This is your critical region, the unshaded region, and that is where your solution will be, depending on the constraint. Yeah. We're going to see some problems to understand that. Yeah. So finding the best solution to limited resource problem, that is depending on the constraints. Okay. Okay. So we have seen how to write and recognize inequality symbols. We have seen how to sketch graphs of straight line equations and find the point of intersection. We know how to locate the integer points in the inequality regions. We also know how to highlight the regions that satisfy the equation, either by shading the wanted region or by shading the unwanted region. So you know both ways now. So now we'll do some problems in the seminar. So meanwhile, do some problems from the textbooks and workbooks. Yeah. And then we'll do lots of word problems to real life problems to understand that. Okay, that's all for now. Thank you.